Oh. Hello, everybody. We're back. Been a long time. Okie dokie. Let's hope everything is working properly. Don't know if there's any people online yet, but welcome if you are. And people who are watching the recording, also welcome. So yeah, I've been working on XR Tools 2 lately a little bit. And I think it's about time we go and have a look at what's been done so far and start seeing if we can improve a few things that that I've been wanting to make work for a while now. No idea if I actually am going to get them to work because the approach that I was using didn't really work out. And we're going to try a different approach today and see if that makes a difference. So, all right, before we start, let me just make sure that my quest is actually running. I should have done that before I started. Let's see. Come on. There we go. Putting up. What? Okay, that's not a good sign. What? All right. We might need to use a different headset today. What the hell happened here? Wow, my quest is bricked. That's great. Oh, that is not good. It was working last night. Okay, let's see if I can reboot this thing and see if that makes a difference. Come on. Ooh, something's happening. Ooh, that was scary. Yeah, yes, it is working. How the hell did that happen? That was really scary. I got like an Android boot error there. All right. So I'm not quite sure what was going on there, but we're back to working. So start Steam Link. Now I'm pretty sure that I am going to have to restart Steam Link a couple of times. There we go, that one. Alrighty, cool. That is running at least, so that's done. All right, cool. Actually, that's a good excuse right now to do a run through, and well, actually, let's have a look at the project itself, because this has been a long time since I've looked at this on stream. So, working on this new version of Extra Tools is still very far away from being in feature parity with Extra Tool 1, but yeah. Let's see if we can bring it a bit closer. So, main thing right now is that similar to Extra Tools 1, we do have our staging set up that I'm using here that will load up a boot screen and then load up the actual project. That is something for later to look at. But it will start by default, we'll start this, which is just a test scene that I'm working with. Eventually, just like in Extra Tools 1, we'll have some different tests that we can look around in. But for those who might remember my previous streams on Extra Tools 2, a couple of things have changed. We just have some stand-in stuff for being able to visualize our character. You can see that I've got some test stairs here, and I've got some slippery slopes in the back. And I just put some walls up and just, create a little room that I can walk around in and test things in. But our main player character is now based on a character body, and we have lots of little components that makes it work. And this is one of the things that makes XR-Tools 2 different from XR-Tools 1. I'm still working through a lot of things to make sure that everything works in this way, but the whole idea around XR-Tools 2 is that we work more with composition and more with decorators instead of, as XR-Tools 1 did, where you subclassed a lot of things. So this is also visible, for instance, with the cubes that we see over here. Why don't it let me select the cube? It's because that's obviously in my world subscene. Did I put that there? Yeah, so we got some boxes here on the table that we can pick up. But you'll see if I open up the box, for instance, that it is a normal rigid body, and script-wise, the only code that's on the script is actually to change the color and the size of the box. There's nothing XR in the script. And that's something that is uniquely new to XR-Tools 2, that we go for a way where, or an approach where you can pick up any rigid body by default. We decorate the object to add additional logic. So in this case, for instance, just like in XR-Tools 1 and in XR-Tools 1 is we have a right and left grab point to limit where the hands can be put. And that's something that we need to work on as well, because just like in XR-Tools 1, I want to add a pose system here and a visualize system here that's not in XR-Tools 2 yet. Now that same thing goes for a character. So one thing that we'll see is that, I'm using Unity terminology here. Forgive me for that one. But I've got a little prefab scene in here for my character body, which is this scene here. But the idea here is that this is just an example. You don't have to use this. You can, but you can also just build your own struct. But obviously there is going to be that you need some basic things in there. Hey, Living Soul of the Time Studio, how are you? Thank you for joining us. So what we see here, again, same thing. We have a character body, which is just a normal character body. Now, in this case, we don't have a collision shape, and I'll come back to that one later. You could, if you just want to have a traditional character body with just a simple pill collision shape, you can do that. Because the whole idea here is that you can mix and match the functionality that we want by, again, adding these decorator classes or composition class or whatever you want to call them. We have obviously an Origin 3D node, and again, unlike XR-Tools 1, this is a plain Origin 3D node. There's no code in there. Same with the camera. We just have our camera. The logic is in these things. So we can see that we have 3 of these decorators here, and I'm going to start with the last one, which is called Physical Movement Handler. And this is a class that you add to the XR Origin node, and that will only work if the XR Origin node has a character body as a parent. That's a prerequisite for this specific implementation. And what this implementation does, it will track how much the player has physically moved away from... Does my camera just stop working? No, it's hiccuping a little bit on this side. So it will track how much the player is physically moving away from where they were last frame. I am really getting buffering issues. It's saying that my stream is healthy, so I'm not quite sure what's going on there. And I don't have any drops. Well, it must be the preview that is being a little bit nuts. Living Soul, I'm well, thank you. Are you working on with implementing a body with VR now in Godot? That is something that is on the plan, is to indeed start looking at a proper avatar at something sometime as well, but we're not there yet. Right now, I'm really concentrating on getting all the basic functionality to be in there. Anyway, Hey, Andrew Wang, how are you going? Nice to see you join us today. And I'm glad that the stream is working on your end. It must be my little preview window that is giving me a bit of a hard time. But yeah, also just going to make sure that my quest doesn't go back to sleep. Okay. So yeah, so that's what that one does. It makes sure that it'll track where you're physically moving, and it will then move the character body to that place. And it will, obviously do that with keeping collisions in check. And then we'll do all the adjustments to the origin node to make sure that everything works correctly. If you're prevented from moving somewhere, let's say that you hit a wall, it actually starts looking at whether the head can move. So the character body will stay at the place that is obstructed, but it will check if the head can move further. And if so, fine. So you can bend over tables and things like that. But if you go through a wall with your head, then obviously it's going to black out the screen and sort of go like, hey, you can't move there. You got to go and back up first. So that's what that one does. The second decorator that is important to talk about, and we'll demonstrate this in a minute, is the locomotion handler. And the locomotion handler is a class that works together with a number of other classes. And it kind of takes the position of the old player body in Extra Tools 1, where it is responsible for taking controller input. And with that controller input, it will move the character body. And the nice thing is that even though this is an XR node and it's targeted at XR input, it can work outside of XR too. You could add this to a normal character body that you put a normal camera on, and you could create input handlers, or we call them movement providers, that take input from normal sources. So that is kind of cool where all that logic comes into it. And we can see then in our main stage, for instance, that I, for instance, here have an XRT2. Everything is now previously XRT2 direct movement class, which actually implements joystick control. So this node here will take input from its parent, so the controller in this case on the left, and this is a bit of a special version. It has all the hand logic in there, but it will take the input from the left collision hand, and it will then work together with the locomotion handler to make that work. The raycast body, again, also is a motion provider that, again, works together with the locomotion handler. But this is a very special one, because this guy controls the collision shape on the character body. So you can see that there is a nice little collision pill here, but one that doesn't hit all the way to the ground. And when I look at my properties here, you can see that I have a couple of things that I can change. So for instance, I can make the torso radius much bigger. You can see that it immediately updates that collision shape. Note that the collision shape in this case is represented by a transparent pill. That is because one of the downsides, if you can call it that, from Godot is that collision shapes that are added internally aren't actually drawn on screen. So that's just a little helper object so that you can actually see what a collision shape is. I might improve on that at some point in time, but that was one little weird thing that I found that yeah, I'm adding the collision shape behind the scene and I'm controlling it, but it isn't being shown. It will show in game when I have visible collision shapes turned on, but in the editor it hides it for some reason. So hence the little pill. But the other thing that it does, and you can't actually see that because, again, it's same sort of deal. It's added behind the scenes, and it's not being... well, actually, I don't think I actually use a raycast object in this case. I think I do raycast directly on the raycast, on the logic itself. Because the second thing that it does, it will actually do a raycast down to see how high above the floor I am. And this will make sure that our character always stays a certain height above the floor, and there is some logic in there to make sure that when I change height, I, for instance, go up the stairs, that it's not an immediately bunk bunk. It has some smoothing applied, and if you jump off of something, obviously gravity at that point is applied, and it'll actually simulate bending through the knees as you land and sort of nicely go back up. And that will be very interesting once we do have avatars, that we will be able to see that happening. The last thing that is cool about this is because that raycast now knows the properties of the floor that we're on, we're actually dealing with that as well. So there's proper slope control. On shallow slopes, we won't move back and forward, but on steeper slopes, we'll slide back if we stand still. If we move over, there's actually in my main stage, yep, over here, there's actually this icy bit, so I can walk normally over the floor, but the moment that I'm on here, then I start sliding, which is a lot of fun. So so that is what that one does. So this is a pretty standard setup for a controller, which is why the prefab has these things in there. You'll also see that there's a static player rig in here. This is still an old implementation. I do plan to redo this. And the idea about the static rig is that you use that one when you want to have your player in a vehicle or something like that. So there's going to be a collection of these prefabs to show you this is how you set this up. You can use it directly if you want, or you can build your own, and you can just reuse these components to get the functionality that you want. Excuse me. So let's go and have a look. So this is the other thing that's changed, because actually the game is running right now, even though you guys just see the there we go. Even though you guys just see the splash screen here, I'm probably going to change the way this works because I like it better how I've done it on my latest tutorial. However, in the headset, I am seeing the normal, press to continue in an actual VR environment. So I need to press my button to continue, and I am now standing in the space. Might help if I turn my other controller on as well. There we go. So, okay. Just going to see if I can see here. So yeah, you guys can at least see me standing here. So this is, again, also we have the spectator view in there. I might do more of the spectator view at some point, because this is still a fairly old implementation of the spectator view. But I myself in this environment, I can just look around and see. I see a little fake camera over there, so I can see that you guys are seeing me. But I can turn with my left controller. That's just how I'm set up. So the left controller is just turn, right controller strafe and move. And you can also see that I've got, hand animations here set up with the buttons, and that's actually using the built-in hand tracking, although we do have a fallback for that as well if that is not implemented. One thing that doesn't work yet very well is picking stuff up. We still need to do a lot of work on that. It's actually something that I'm hoping to do a little bit of work on today. But for instance, I can also go up these stairs, and you see that works very well. Now, unfortunately, the camera doesn't follow me yet, so I hope I'm not moving too far away from you guys. But yeah, I can jump off of this. Now, when I come over here, you can see that I actually can't move up here. I can only go up here if I'm not, if it's not too high, and it will adjust. The other thing, of course, is just to show that off, is I can move to this table, and now I can't move further than where I am on this table. I'm hitting the table, but I can move forward. Oh, I can actually not. There is a mistake there. I need to figure that one out because it actually doesn't allow me to go over the table completely. Well, that's a bug to fix. So that is not supposed to happen. I don't know if you guys could see the screen go black. I'm not sure if I'm doing that inside of the spectator view, but yeah, that is a bug to fix because that is only supposed to happen if I try and move through the wall. Then obviously it has to go black. So that's pretty cool. something to fix, something to look at. Next thing, let's see if the camera will follow us properly. So, over here at the ramp. So yeah, I think you guys can see me. So I'm going to go over this very shallow ramp first, and I can just walk up there, and you can see that when I'm standing still, I'm not moving. I'm nicely standing on this ramp. But if I go to this slightly steeper ramp, you'll see that I'm actually sliding backwards. So I'm trying to go up, and I'm being pushed back off. So this is, if I remember correctly, that one is a 30-degree ramp. I think it's set to 15 degrees at the moment. These are all settable. But yeah. And then obviously, if I look at one of these much steeper ramps, I can go up here and it will push me off even quicker. And I can't even get up this one. Well, I can try with a little bit of a run, but it will push me off quite quickly. The last thing is, you'll see that if I move around and I let go of my joystick, there's a little bit of a slide in there, but I stop quite quickly. If I go onto this this icy bit here and I let go, then oh, I am sliding for real. Like, I let go and yeah, I'm sliding because there is no friction on this surface, and that is properly being accounted for. So yeah, that is as far as I've gotten with this. Although I do need to figure out, why is my head logic not working correctly? Might actually be that I am just not allowing myself to go forward enough. I'm also bouncing a little bit right now, so there's obviously something not entirely good yet in the bounce logic. But this is all pretty new stuff, so little baby steps, little issues to still solve. Cool. That's how far we are right now. Cool. Yep. Alrighty. Alright, cool. Yeah, Roman, the leaning over tables was something that for the longest time wasn't working in ExtraTools 1. Now we did retrofit that or a similar solution like this in what you call it? In ExtraTools 1, in release 451, where it now does the same. So instead, well, it is optional in ExtraTools 1, but again, same thing. Instead of just going immediately, well, I think in ExtraTool 1 you would always be pushed away from the table if you try to lean over it. But it should now have a mode where you are actually able to lean over tables. I've got a print somewhere. I wasn't even realizing that, so I probably need to clean that up at some point. Let's actually do that first. Now that I see that, boom. Find and found. I guess that is that one. So I was testing my my sliding on ice. Well, Anyman, that is just a matter of whether you want to use that, right? So it's, in this case, it is driven by the fact that when we look at my world, and we look at my slippery slope object here, like here it is, you'll see that there's a physics material on this, and that that physics material has a friction of 0.1, and that's what's causing the sliding. Now, I guess it would be fairly easy to turn off the logic completely or create something for that if you don't want the sliding at all, although that might be game breaking if you have a slippery environment. But that is all handled by the raycast body. So like that. Not much space here. But yeah, if I go over here, it checks what's on the floor. If you find on the floor, here it's calculating our friction and applying that. So obviously that would then be a matter of overriding this logic and saying, nah, I'm always going to have my floor friction set to 1. I'm not going to do this. So there would be a little check that you do here. And that floor friction is then picked up by our locomotion handler and doing that. Noibat, when it comes to extra tools itself, there isn't a whole lot that matters as far as optimization. This is all control code, so this is 1% of your budget. So it really, it's really the rendering part that is important, and it really depends on what sort of PC you have, and especially what sort of GPU you have in your PC. Godot runs pretty well on pretty low-end hardware, even for VR. You might need to switch to the OpenGL renderer to get the best results performance-wise. But the main thing is that we rely on something called multi-view as an extension, and not all graphics cards support that really well. And that is something, especially on older cards and on older PCs, we do have some difficulties that sometimes that is not supported. So that is the thing to just try out and just, download Godot and grab one of our demos. I would suggest in this case to start with Extra Tools 1. You can actually go to the asset library and you'll find the Godot Extra Tools demo in there. When you create a new project in your startup screen, you can immediately create a project and download the demo and play around with it. And you can just see how well that works. But UGVR, in the end, you do need to have a PC that's capable. Now, if you have a Quest, obviously, there is always the option to run the project on the Quest itself instead of running it on your PC. And, stuff like Extra Tools and, the Extra Tools demo, they run fine on the headset. So that's an option. That's, if you don't have a good PC that runs VR, then that's something you can do. And you can still do development on the PC, obviously, but you would just push it out to your Quest and run it natively. Okay, so yeah, and you can even run Godot on the Quest itself, but you can also run Godot on your PC, do your development on your PC, and then just push out your game to the Quest. It's really depending on what you enjoy. How am I climbing on grab locomotion work in Extra Tools 2? Anyman, I have not gotten there yet, but I have given a lot of thought about that. And what I'm hoping to achieve is kind of the same as what I was talking about earlier about the rigid bodies, that I'm trying to work to, hey, I can interact with everything, and I just modify the behavior by adding nodes to it. So one of the things that I want to do is that if you try and interact with static geometry, we have a natural way of working with that. Now, you won't be able to just grab any surface by, and climb up to any surface. I do want that to be a decorator to say, like, yeah, you're allowed to climb up on this wall, or, have smaller objects that you can grab and climb up with there. But then all the logic for actually controlling the player body and how the player body moves, or if you push down on a table or things like that. That is something that I want to build into the system itself so that you don't really have to worry about that. And it should be a lot less, it should have a lot less friction than the way that we did it in Extra Tools 1. I hope that's a goal. I haven't actually gotten it to work yet. So, hey Teddy, I had a suspicion that was you, but it's great to see it confirmed. I hope you're doing well. I should have realized, seeing that you are working on the VR injector. Cool. Sorry, I need to have a drink. All right. let's have a quick look and see if we can debug the head issue. Figure out what is going wrong there. Now, I believe that is handled in physical movement. And that is somewhere over here. Yep. So let's see. Character body, shape, head. We set it up with an excluding here. I'm still, oh, it's still ready. So I'm setting up the shape here, but I'm using the head collision radius here. So let's have a look if that is set to something sensible. Might be a little bit on the large side, but I don't think that's actually a bad thing. I probably need to create some sort of little visualizer for that as well, so that you can actually see what it's doing. Oh yeah, there's also height calibration in here, so that's why I was standing up, even though I'm sitting down on a chair. It will do a calibration when the level loads, and assumes that the character is standing, so it'll add some height to the character. But then obviously after it runs, if I would have been standing and I bend down, or if I stand up, kind of like what I showed in my tutorial videos, you will obviously see the character grow and shrink. And then obviously the raycast body reacts to that, right? So the raycast body is continuously checking how high is the head above the origin, how high is the origin above the character. That way it figures out where your eyes are, and then it calculates down from there how big the character should be. Okay, so yeah, I haven't tested this yet, but there is the ability to walk into rigid bodies, and you will push the rigid bodies around the area, so we should be able to push things eventually. And then here we got our friction, move, and push. So we're not doing the head logic here then. I thought we were doing it here. I guess we are doing it in the locomotion handler then. Or is that my problem, that I thought that I implemented that and I haven't actually implemented it here yet? Or maybe I lost it accidentally, because I suddenly realized it should be here, because there's my ready function. Oh, I'm in the wrong one. No. Ah, I think I was scrolling in the wrong one. Yeah, here we go. I'm just looking at the wrong code. So now we need to look at the physics process here. So this is doing the camera update, making sure that we're facing the right way. Then we're trying to move. We do a move and collide in this case, because for the normal move, we're not doing the slide logic. So yeah, because I'm only on the locomotion handler, I'm doing the pushing logic. On the physical, I'm currently not. But eventually I should be calling the same logic as I'm calling over here. Where was it that we were just looking at? So the push rigid bodies. So probably I'll move this logic somewhere more central at some point, so that I can also call it from a physical movement handler. And we do the same tricks as I did in my tutorial. I'm moving our origin back in. And then here we go and look for our fade. So I'm getting my space from my character body, getting my states. And then I'm using my shape query that I've already set up to do a movement from where my head currently is to where my head is supposed to be. So the question is this correct? So we're looking at, no, this is not correct. Is it? No, this is not correct because this actually moves the camera above our extra origin point. And our extra origin point can be anywhere, right? Because that is my center of my play space, and I'm continuously moving my character body, and I'm moving the origin point in opposite direction to make sure that my character keeps being above the origin point. So what I actually need to do here is not use the global transform of the origin, but instead I need to add the height of the origin. I might even already have that. Yep, I have that here. So I need to add that to there. And now we need to use the character body global transform to place that in the world. So now I have the point of where the player's head would be above where the player is currently standing. And I'm now moving it from there to where my head should be. So in theory, that should be good. Yes, to a degree, Andy man. So this is somewhat simplified logic where we're finding out which bodies we are colliding with, and we're looping through all the bodies that we have collided with. We check if that is a rigid body, and in that case, we look at the velocity of the character, and we look at the velocity of the object that we're colliding with, so that we get a delta velocity, and we calculate the strength by which we will push that body away. And we do that with an apply impulse with that strength that we have calculated, and the position of the collision. Now, because we're applying an impulse, that takes the weight of the object into account. And because we are taking our velocity into account and this thing called collision push strength factor, if you set that push strength factor to something that is sensible for that player's simulated weight, then yes, it will. Because one of the things that is interesting about Godot itself is character bodies don't have weight. So at some point, I would love to improve this and actually calculate this based on the weight of the character and figure out, okay, what is the correct strength that we push things away with. But at the same time, it's also one of these things where the heavier the object is that you push against, the harder you push, right? It's not just the velocity of me as a person. How fast am I running into this object? So if I could be standing still and I could just be pushing with my hands or pushing with my body against something, and I can obviously exert a certain amount of strength or a certain amount of force. And yeah, we don't really have a way of knowing because the player isn't actually physically pushing against something. We don't have a way of knowing what that accurately is. So this is a good enough approximation, I guess. But there's probably a lot of tuning and stuff that I can do with this. All right. I hope the stream is actually behaving well, because my preview is misbehaving like crazy, but so far I'm not getting any drop frames, and so far YouTube is happy. So keeping my fingers crossed here. Okay, let's try and see if our fix worked, and let's also hope that I haven't been thrown out of Steam VR yet. It's something that usually happens. Nope, I'm still in here. Very good. Play. Oh, I always keep forgetting this. One of the downsides of the changes is I cannot control anymore where this bloody window opens. Something I should deal with eventually as well. All right. Cool. So let's see if this makes sense now. Yeah, I can move over. I probably should actually try and stand up a little bit. Like, yeah, I can move over my table now. Now let's see if I still get it to go black when I try and go, yep, that still goes dark. So that was the bug. That was luckily a fairly easy fix. Cool. So, now I do have to say, I'm not sure if my height adjustment is working right now. I should probably get some extra info displaying somewhere so I can actually double check, because I might have just made this table very high. But it feels like I'm actually, that my height is, oh, that's not good either. Okay, I need to fix that one. There's collision shapes on my hands, and when I move my hand too close to my face, that logic that we just wrote is suddenly go like, hey, I can't move my head through my hand, so I'm not allowing you to do that. Obviously, I need to make sure that my hands are excluded from that logic. That's hilarious. You guys can't see it, but my screen keeps going black, which is funny as heck. All the little things. So yeah, it feels like I am actually not tall enough right now. So either my height adjustment is not working correctly, or the logic for making sure that I'm high enough is not adjusting my height correctly. But that is just tweaking values eventually. I can actually have a look at if this works. No, doesn't make a difference. No. Okay, cool. So it might just be that the table is too high, but I have a feeling that I'm actually not tall enough. So let's go and fix that that problem and see if there's a nice way to do that. Because of course, how do we find out which things we want to exclude? Because normally, you know, in ExtraTools 1, we actually used physics layers for that. So in ExtraTools 1, we made sure that our hands and our player and other things are, I love, by the way, how I'm putting my head on the table. That is so cool. Well, Anyman, that's actually something that should be part of this system. First of all, if I was actually be standing up, and obviously I crouch down, my height would change. That's all part of the raycast body logic. So either my actually, let's have a look at that real quick, because that should be handled over here. It might. There we go. Need to make some room. It might just be that my logic isn't being called. Although no, I've got here on pose view centered, and on the vision session visible, and then initially I run it as well. So that should be called when we first come in here. So it does a center, make it a head tracker, the head transform. And the important bit is oh. Oh, I redo the, oh yeah, because on pose recenter, I'm only doing it if I've set this up and I have a camera. Okay, so it's in calibrate heights. See, I should really be reporting this stuff and putting it somewhere so that I can actually debug this stuff. Yeah, we could just put that in as a test just for now. I kind of hate doing this sort of polluting, but as long as we remember to remove it again, we should be all right. Unless I want to have it as a function, that would maybe be a good idea. I could probably do that. Just keep that in as a function. Um, huh. Why not? Make that false by default. Okay. Then we obviously want something to actually show that with. Like info. Make that a label 3D. All right. And we need to figure out what do we want to show, because that's something that I probably want to go and... Hey, Picker, how you going? I just wanted to put in a physics process. Probably. All right. Because one of the nice things is when you look at this, obviously our physics movement handler is going to be here as a node, and I've made sure that all these nodes are node 3Ds, so we can add stuff to that if we want to. It's really cool. Now our physics process. Do we have a normal process? No, we don't. A little bit of overkill to put this in physics process. So shall we just add a process to this? And obviously, if we are an editor, this is the downside of having tool scripts. I'm gonna make sure that we don't run code that is only designed to be in what I want to say. That is only designed to run in runtime. So if we are showing info, we're going to build some logic here. If not, but we do have our debug info object, we are simply going to say debug info.visible is false. So let's make sure that that is done. Now here, what we're obviously going to do is if we don't have our debug info, we're going to go and create that. So that's going to be a label 3D new. Boom. And now he's going to say at child debug info false, and we're going to make that an internal node. So a little bit overkill when it comes to stuff that we're only adding in runtime anyway. But this is very important to do if we actually want this node to also work in our tool script, because it makes sure that we don't actually see the node in our node tree, which could obviously lead to problems if stuff is internally handled. Now, the other thing that we obviously want to do is at the end is make sure that our debug info is visible. But we're also going to go and place it. I'm just going to be on this one for just a second. Oh, and that's why it keeps going back to that. That's interesting. I'm just going to add a label 3D here temporarily. We're going to remove this. Go away. We're going to remove this. I just want to see what properties we need to change. The nice thing about just adding this is now we're basically in the same state that we are after this gets run. And now we can see what things we need to change. Now, the first thing that we want to change is, let's actually give this just a little bit of text so that we can see what we're dealing with. The first thing that we want to do is we want to make sure that is on the same height as our camera, and we want to move that forward a little bit. Now, remember, we are not doing this in relationship to our to our character body. We're doing this in relationship to our our XR tools. XR origin. So we're going to have to base that on the positioning of our camera. Should be fairly straightforward and easy. So that's the first thing that we're going to do, is we are going to move this. And we're obviously going to do that over here because that's something that continuously needs to be tracked and changed. But we will do a debug info dot position. I'm going to do this in local space because, oh, that's a good one. No, that's fine because the physical movement handler is at the same place as our origin 3D, so that's cool. And that reminds me, that does mean that we need to go and grab our camera info here again. So let's see where we can copy that from. Just going to go and copy this so that we have our camera. Because I don't have access to our node, we're doing everything behind the scenes for this. Go, boom. This really should be in a helper function, but I can't be bothered right now to do that. So this can be t.origin plus t.basis.z times vector 3. We want to move that only in the horizontal plane. So let me think. Origin basis z. So let's say that we want to move that. Oh, actually, let's see, how far did we move this? It's 0.7. I'm just going to go for 0.5. We're going to zero out that, and we're going to do that. Cool. And now, look at. Okay, is that going to be a local? No, I want to do that. So I want to make sure that we do this the right way. And this is going to be T origin, vector 3. I think that's true. We'll see if that's true. Just to make sure that the text is always facing us. But I believe that was not like that. And we obviously need to indent that a little bit. Okay. Yeah, we'll eventually make that work a little bit. I need a helper function that just gets my camera transformed, but we'll pretty that up eventually. So that is all being set now. Now let's just go just for testing. So text is hello world. Obviously I'm just gonna hide that one. I'm not actually gonna remove it because I want some more info from that in a minute. But for now, I just want to see if this bit works. So in our process, if we have debug info, we add our label if it doesn't exist yet. We use our head tracker to position it. We just give it some dummy text for now and make it visible. If we have debug info off, then yeah, I guess it's off. So with that, I now have our debug here, and I can say I want to turn that on, and hopefully always double check this because sometimes that goes wrong. Yeah, that's perfect. So that has captured that. Cool. All right, let's see if we have a hello world in front of us or not. As the case may be. All right. There we go. All right. So I don't see my text. Now you guys might see something because it might be behind me. Yep, it is behind me. Okay, that's funny. All right. Now, let's have a look at my physical movement logic. So I guess I need to subtract that. Okay, so now one thing is it is too close to my face. It's way too big, but it is now in the right position. Now this is one of the things that obviously I love about Godot, that I can just make an edit like that in the code and it immediately shows up while running. I don't have to restart everything. So, okay. The first thing that we're going to do is we're going to move this back a little bit more. The second thing that we're going to do, and for that, I'm just going to go and open that again. Is we want that to be smaller because our default for our label, the default pixel size is 0.005, which is great for normal games. Not so great for VR because it basically means that every pixel of our text is half a millimeter big. So, 32, what you call it? So let's say that's 32 pixels high text, font size of that. I think actually we're going for 64 here. No, we're going 32 pixels. That means that we are 16 millimeters high. So that is text that is nearly 2 centimeters high. Well, that's a little bit on the big side. So we're going to make that a bit smaller. That might be too small. So let's go for 002. And again, I'm just setting that up here so that I can see what's going on. Obviously, we're not using this label. We're going to delete that label eventually, but it helps in setting things up. So that is something that we only need to do first or one time. So we can just go here to debug info and we can just say pixel size is 001. So that's really a nice thing of when we have that label here is we can start going through the things and everything that is set here will be will be our default. So anything that we need to change, that is all that we need to change in here, which is nice. Okay, so now we actually need some text. Now I kind of like doing something like this, and then just doing text here so that we do a single formatting. Now the nice thing here, of course, is we have our pose tracker. Actually, let's go and move that up a bit then. Let's place that over here just so that we can actually add things as we want. So here I can do a text and I can say head transform. Now head position. F. And I can go and say T origin. Actually, I only care about the Y, so I'm just gonna put the Y in here. Also on a new line, so head height. We can see how far our head is above there. Now I also want to go and say that's called height adjust. Can't remember what we called it. Yep. Just. And actually, what? Right. Let's just go and do it like this. Let's say here, origin dot y, which means I can actually go and do this as a single one. There we go. That makes a bit more room. Okay. Actually make this even nicer and just do it like this. Yep. Eye heights. I want to add these two together. All right. All right. So, now in theory, all this works the way that it is supposed to. Then that should nicely add up to whatever we've configured here at 1.6. Obviously, as I move up and down, it will slightly adjust, but it should be around the 1.6 mark. I don't need you anymore. So let's see how close to that we are. We even are close to that. Okay. Oh. That is not working the way that it should be working. That's interesting. It is not putting any info in there. Well, you guys have to look in reverse. Why is that not working? That should be a percentage. Maybe it's just because I didn't have all the things in there that it just panics out. I do have a lot of errors here. Yeah. The process string is not good. So instead of only doing what I can do, I'm just not going to do any of it. Why not? Oh, and of course, it helps if I move the screen so that you guys can see it. There we go. Wonder how many times I've had that open without you guys seeing anything. Now that looks really good. Now again, you guys can probably not see it unless I go and stand under the camera here and then turn around. Maybe now you guys can read too. But yeah, my head height is 1.2 because I'm sitting down. My height adjust is 0.4, so that is how much I've increased the height of my player. And my eye height is now 1.6, which means that my character is about 1.7, 1.75 meters high. So that part works fine. So the fact that I feel that I am way too low either means that my table is way too big, which is something worth checking, or it means that our raycast logic makes us not tall enough. So, with that all working, we're going to repeat the same approach. Let's do the hands thing as well. We're going to repeat the same approach for our raycast logic. Yeah, no, the problem is my game window keeps opening up, not in the area, because I've got a widescreen monitor, so I've got an area set up for the editor. I keep forgetting to drag it into where you guys can see it. So hopefully it did show up in the end. Yeah, that was a bit of a. I'm gonna just put meters in there just to make that visible. However, I am now going to go over here and I'm going to say I'm going to turn that off, but I'm going to keep that code in there. Probably clean it up at some point. I'm going to keep that code in there as a helper. Now that means that we can do almost exactly the same. I'm going to copy that. I'm going to do exactly the same here in our raycast logic. Oh, and I already have a show debug shape here. So in this case, I am not prefixing this, but that's fine. So when I go over here, I've got. Oh yeah, that's for the collision things. Okay, save. Recast. So I'll turn it on as well. Okay. So we have that. And here we're going to save our info. Label 3B. There we go. Okay, so now in this case, everything is handled in this function called process locomotion, which is actually called by a locomotion handler. So we're just going to have to put our code in there. The nice thing is that we have our head position here already, so we can actually use all that stuff directly, which is nice. Also, our raycast body in this case is obviously on a different level. So we're just going to put it at the end here. Whoa. No. Show debug show info. Okay. So in this case, we're just going to say debug info dot visible pulse. Okay, and now from our physical movements. Okay, we're just going to copy some of this. There we go. Now this is actually nice because we are orienting our player correctly. So I can actually make this way easier by simply saying debug info.position is vector 3. That's going to be 0. That is going to be head height, which I think we've already got here. Oh, that's in world origin. Oh. Oh no, I know. I'm just going to use that. And then we're going to move it slightly there. Which also means that we probably need to rotate it 180, but I'm going to leave it the way that it is. It might actually show up in the right orientation right away. Because again, we're anchored to our character body, and our character body moves as a term ahead. So it makes it nice and easy. So let's verify that. And just say debug info. Next is do our hello world again. All right, see how well that works. Don't forget to do that first. Here we go. Now everybody's messaging me all of a sudden. All right. I wonder at this rate whether we're actually going to get to doing the head logic that I wanted to do. Let me... No. Okay. I was actually expecting that to be visible, so... All right. Cool. All right, let's think this through. If we don't have a debug info, actually, first of all, let's see if we have something with our... No, that is on, so that is good. Our Raycast buddy is there. Is there a reason that it might have... So the only chance is that we don't have a state we return. We don't have a pit controller we return. If we don't have head tracking we return. Well, all that stuff is working, so I'm pretty sure that that's not our problem. We got a label, set a pixel size, add our label just to our node, so it's going to be on the raycasts, and then we position it at eye level. So it should show somewhere. Okay, let's do this. Comment that out. Let's run this again. Now, don't worry, I am this time on purpose not moving that because I just want to. No, there, don't worry. Because I want to actually go here, and we're going to go and have a look behind the scenes. Here's the main stage. Here's a character. Here's a raycast body. Doesn't have a label. Okay. Our show debug info is false. Oh no, that's a default. The current value is true. Okay, so debug. Step into, yeah. You have a debug info. You have a label. So why aren't you there? You have been added. Okay. What? Try this again. Again, just to prove that I have this running. All right. So this time we don't have a debug in that label. What is the button key? 11. We're adding it. Eye level 1.2. That's actually wrong. There's a bug, by the way. Found a bug. Okay. Continue. So. What? Character body. It has not added our label. Is there anything in the debug? Maybe parent node is busy setting up children. I am not allowed to do certain actions at certain times. That's why that's suddenly moving wrong. Okay, so we can deal with that. We're just gonna call defer that. Okay. However, let's go and make that a bit bigger. Let's actually see if that works now, because that should do the trick. Let's move that. Oh, look at that. That looks promising. Hello world. I can see it. Ta-da! Okay, so that was all. We were calling add child at the moment that we're not allowed to call add child. It's a little bit annoying. it works. Now, the problem is, or the thing is, when we just hit that breakpoint, we could see that our eye level was wrong, but let's go ahead anyway. And let's put that in there. Michael, I am working on the new Extra Tools 2 right now. Oh. Can I do this while I put my headset on? Yep, there we go. Alrighty. 1.5, no, 1.5, 1.6. So that was just a fluke that we saw that as 1.2. So it definitely knows that we're at the right height. So just for you guys, don't know if you can read that, but yeah, it says almost 1.6 meters. All right. So now the question is, where am I actually? What is my real eye height? Okay. Cool. For that, we're going to cheat. Okay. That's the same trick as we did before. Pull that current level. But what I'm going to do here, and this will be a frame behind, but that's okay. Oh yeah, because I'm getting the head position, I'm getting the eye level there. Oh yeah, because the whole character moves down if I bend my legs, so to speak. All right, so that means, how do I get my real heights? I get that by taking let's see, am I missing something here? Torso heights, head heights. Yeah, right. Yeah. So we are taking we need to store what our actual intersection point is. It's collision heights. Where am I calculating your collision heights? All right, so okay, we're gonna set that like that. And then we're just gonna go and calculate that over here. All right, so didn't have a collision. That's going to stay negative. That's perfect. Here we go. That's perfect. Because that should be 0. Yeah, because that is measuring from Right, so this is how high. So I'm going to make this something ridiculously big so that it stands out. And here we're going to make, oh, let's copy this. Television height. All right. I think that is going to be high level minus collision height. Okay. Let's have a look and see what comes up with. I might be getting that wrong, but because it would, you know, make something really crazy like making it 99 or higher if you're there. But yeah, we can now see. All right, so he's slightly shorter than we should be, but that's okay because that's our PID logic. It's pretty close. Now, as we move this, we should see that bump. As we jump off, we saw that quickly. Well, you guys can't see it too well, but I can. It jumped to 100 real quick because we're not above the ground. And then once we hit, this would have been nice to have this graphed, but actually one of the things that I should have done with this is not use label 3D, but use also a normal label, and then it would actually have shown up in the interface for you guys. However, point is, this is working the way that it should. So I probably need to tune the PID control a little bit because there's a little bit of shakiness in here. But I am definitely the height that I should be. So doing this. Yep. Yeah. So. That's funny. Huh. So is it just illusion? Is it? Did I make that table just really, really high? Oh, let's have a look. Still good to have this debug stuff in there. Always find use for that. World. What's my table? Table's here. 1 meter high. Huh. It feels so much lower. Well, it's a little bit over 1 meter because it's also got a thickness of that. So it does feel a little bit on the high side. All right, one thing that might be nice is actually have a fake measuring tape in my world. Let's create that. Let's actually put that against that wall over here. There we go. So I'm going to go and put a label 3D here. And let's go and zoom in a little bit where I am. Oh, the shadows are not behaving very nicely there. Okay, let's do that. And yeah, it's like that. Now, oh, that's 90 degrees twisted. Okay, that makes sense. No, transform 90. Might need to be minus 90. We'll see. Nope, that's the wrong way. This one up. There we go. Okay. So that again. Okay. 1 meters. cool. Yeah, that'll do. All right. Make that 20. These are like little nice things to add in here, actually. Four. Five. Let's speed this up a little bit. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. 60. Oh. Fix that up. That's now, of course, wrong for all of them. Okay. Okay. 80. Sorry, guys. I realize this is a little bit boring, but oops. We should have this done in a second. There we go. Okay. 1. cm. Um. 2m. 30 cm. Pretty sure this is a fairly inefficient way to do this, but whatever. It'll help. It'll do what it needs to do. Everybody needs me when I don't have time. Haha. Okay. Almost there. Couple more. Huh. Did I miss one? Oh. I didn't scroll down far enough. I thought, like, where's the 2-meter one? All right. I think we need to make our wall a little bit taller. There we go. We have a measuring tape. All right. So in theory, if I look straight ahead, I should be at eye level and know what that is. And of course, again, I forget to, where's my cursor? Here we go. Whoop, there we go. Okay, you guys should be able to see that. All right. Cool. All right. Oh, I can actually use my the text that I'm printing, and it is nicely it's nicely at the 1.6 meter mark. So I am the correct height. So it's purely an optical illusion that I think that my table is that high. Or maybe I just made my table too high. That's very possible. Although, you know, I'm kind of, oh yeah, that does work. That's right. I do have the pushing. Yeah, we just made a very tall table. And it just, because I'm sitting behind a physical table, you can actually see with my hands, I'm resting my hands on my physical table, and they're just about on the height of the table. So it makes me feel like I'm sitting down, but the table is just very high. Because as we saw from the other debug information, I'm actually at 1.2 meters eye level sitting down. So I'm actually standing up. The logic is actually working the way that it's supposed. Still need to fix that one. But, oh, fell off. But yeah, that's actually pretty cool. All right. Well, I'm going to keep that bit of debug information in there as well. I'm probably going to clean it up eventually. But, well, we took a big detour just to figure out that the logic is actually working the way that it should. So all that was wrong so far that we found was, oops, was the way that we calculated the position of the head. All right, cool. I'm actually happy that we added this because it's a nice visual confirmation that we are on the right height. So gonna keep that in there. That is actually handy. I am going to go back here and turn that off because I don't want that debug info in there. But I am going to leave the code in there because I think that is very handy to have. I'm also going to quickly fill up my glass because I'm thirsty. That's the end of that little. So, big detour. All right. Now, the next problem. That's a really good one. Is our left collision hand's collision logic colliding with our head? And as I was explaining before, what we did in ExoTools 1, don't know if I'm actually exposing that somewhere over here. That is, I think, a rigid body. So yeah, so we have our collision here. In ExoTools 1, we actually set up a bunch of different layers. But on purpose, I've not done that for ExoTools 2 because I found that a lot of people weren't aware of the layer system and got into trouble as a result. But also, people who do use the layer system might already be using them in a certain way, and our system would collide with that. So there is quite a bit of logic that prevents things. So from one thing that's, for instance, in here, just need to make some room. So we're adding our collision shape here. And we're adding a collision exception with our parent body. So our hand is not colliding with our our body, which is really nice. That's what we want. The problem is that we don't know what those exceptions are when we're doing our physical movement. Now, when I set this up, I am excluding the character body itself, which is really nice. But I think what we need to do is take this further. Now, the problem that I have is the order in which things happen. Because our character body will have exceptions. So I think that we're actually going to build this exclude array on the fly. All right. I'm going to go and move this to where we're actually doing our query. Where are we doing our query? We're doing it over here. Okay. Now I think I need to build that array first. That's just an array with. Okay, cool. So what if I do it like this? Actually, let's go and do it like this. And we're going to say var exclude array grid. So we're going to define an array with. We're going to put our character body in there by default. And we're going to go and assign that. Sweet. Now we want to add to this exclude everything that the character body is already excluded with. So, Jesus, WhatsApp, stop bleeping at me. No, I'm looking at the wrong place. Where are we here? Where's my collision hand here? So collision parent, add collision exception with. Yeah. Okay. We should be able to query what the get collision exceptions. There we go. Okay. Actually, let's just call that that was an array of physics. Body 3D node is character body dot get collision exceptions. So we get the list of other exceptions that we have. Now we're going to do for exception in exceptions exclude pushback exception get rid. All right. So now we should be excluding every object that is currently having, and this is important because we actually get exceptions for the thing that we're holding as well. Come on. Here we go. So we can still do that. We can still do that. We cannot do that. Perfect. I can now do this without it going black, but with that exception, I should even be able to, come on. Yeah, because that would have normally gone black as well, because the moment that I pick up an object like this thing, that actually becomes, that's now a rigid body that is moving around. So that would also be able to collide with me. And before I did the exception logic for this, I could actually move this into my collision shape, and it would actually push me back because I'm now colliding with this box. So the moment that I pick up this box, I'm actually adding a collision exception between this box and my body to make sure that the box doesn't collide with me. Because yeah, I would be exerting a force on myself. Now, at some point, that probably needs to be enhanced that I can actually hit myself, but instead of it pushing me away, it should just, I should just not be able to push the box into me. But for now, that is good enough for what I want to be able to do. So yeah, I think we need to start doing something about the wobbly hands. Actually, before we do something about the wobbly hands, this is actually it is funny though. Cool. Before we do something about the wobbly hands, I actually want to drop my controller on the floor. That was a really good idea. No, that wasn't what I was planning to do. So excuse me while I pick up my controller. There we go. I just want to safeguard all the changes that we've made so far. So bear with me while I do this, and probably that is not visible to you guys. And this gives me the opportunity to show something else, because this is another change that I've done between XRTools 1 and XRTools 2. XRTools 1 is one big repository that contains the XRTools demo, and then has the add-on inside of that. Now here, you can see that I'm doing the same things, right? I've got my XRTools 2, I've got an add-ons folder, and inside there is a Godot XRTools. However, this is actually a submodule. So you can see that I have my files in here, but they are on the root of this folder, of this add-ons folder. I actually have a second shell open here, which is in the root of XRTools itself. And if I do say this here, you'll see that here I'm actually on a branch called demo. And this branch has the XRTools 2 main branch as a submodule. And the idea here is that if you want to use XRTools 2, you'll have two ways of deploying this. One is you can download XRTools 2 as a zip, unzip it, dump it into the add-ons XRTools 2 folder, and probably the zip will already come with those folders pre-prepared. It's something that I'm planning to eventually add into the CI that builds releases. Or you can create the add-ons folder in your project, and then you can submodule XRTools into there, just like I'm doing with the demo. And the nice thing about submoduling is that that folder now creates a link between your project and the XRTools 2 repository. You can pull new versions in much easier. So especially when you are used to using Git, that's really nice. That really helps. So I am going to go and from this create a new branch. I'm going to call that fix movement issues. Cool. So now I'm in that. And now I'm going to say, I'm going to add that. And I'm going to say fix several movement issues. And now I'm going to push that. That's just origin. Origin. I'm not going to go further than that. That'll create obviously a PR on the repo, and I'll eventually clean that up more. So that has now safeguarded those changes. Normally, what I would do right now is that I would also check in my demo in the same way, but because the changes that we've done to the demo are not really specific to these things, we'll eventually probably end up merging this and then doing something with that. All right. Now, obviously, my changes for my hands, I want to have separate from those changes. So I can do another Git checkout -b, and I can do improve. No, use it hands. I have now a new branch for that, and then my changes on top of the changes that I just did, I can put in that branch, and I can manage those separately, which is handy. Cool. So, all right. I am going to go and close all other tabs. Eventually, we end up with a bunch more tabs. But I have a PID controller in here. And I've got no ideas where I've got it in MISC. Okay, well, it'll do. And this is a linear PID controller. And it is coming from this guy over here. Now, let me quickly go open up that page. So this is a nice description of how PID controllers work. But he also has a nice implementation of his PID controller. And I've ported that over to Godot with a few tiny little changes. This PID controller is a linear one, and he also has a here. He also has an angular one. Oh, it's actually Unity code that I converted to Godot. Okay, so where is the actual PID controller? Is it this one? Hello. Oh. There you go. Nope, it's not. This is a packaging thing. Here we go. Oh yeah, he had an update, and then he had an update angle. Cool. So I'm actually going to create a duplicate of this, I think. Yeah, why not? All right. Duplicate. Angular PID controller. Because the movement works relatively okay-ish. Oh, PID is a oh, what's the full description? He's got it in here somewhere. It's a piece of logic that calculates a value that allows you to move or rotate an object to a target position or a target rotation or a target value or target rotation. While trying to maintain momentum and smoothing out that movement. So in a case of like a hand in VR, if I move my hand from here to there, now I can obviously just position the hand here now, but I'm actually moving the hand from here to there, and and if I want to apply correct physics and make sure that as that hand moves to the new location, it collides with anything in between and it moves them, or if it hits something that it can't move through, that it stops there, things like that. I need to calculate the force that is required to move the hand from here to here, and I need to apply that force and move the hand in that way. Because if I just move it, or even if I do a move and slide, I don't have that force information, and I'm limited to what I can do. So I'm doing that for the player body, and it works fairly well for the player body because the player body is not bound to anything. But when you have a hand and you pick up a box, and this is one of the big differences between how XRTools 2 works and how XRTools 1 works. In XRTools 1s, we would pair the box and we just indeed do a move and slide to move the hand, and you can collide with things, but you're not really applying forces. So you're not really reacting to the fact that this box is heavy, or you're holding this box in an odd place so that there's a lot of momentum. XRTools 2, the moment that you pick up a box, actually creates a physics joint between the hand rigid body and the box rigid body. And as the hand rigid body moves through proper forces in the physics engine, the physics engine will calculate the fact that those two are joined. It will calculate how to move that properly. But you have to use forces. The moment that you do something like move and slide, you're basically, the problem that we're trying to solve, you're now putting onto the physics engine, and the physics engine suddenly goes, oh, the hand moved from here to there. I don't know how much force that took. I have no idea how to apply that to the box. No idea how to naturally move the box. I have no idea how the box now applies forces back to the hands and actually prevents the hand from moving there naturally. It doesn't work. So I did a lot of experimentation a couple of months ago where I'm trying to calculate those forces as accurate as possible. And I found out that the physics engine takes shortcuts. And that's the best that I can describe. And it makes sense because a game engine's physics engine isn't an ultra realistic engine that does exact physics, because that would make it slow as heck. So it's always an approximation. And the really weird thing about that was that actually when I was moving my hand, I could actually apply forces to my hand without worrying about what I was holding, even though you're supposed to apply larger forces if you're holding heavier things. And that worked itself out somehow. But then rotation, it completely screwed up. It had no idea what it is. So with a pit controller, instead of trying to calculate the exact force and the exact angular momentum that I need to position my hand, what I'm doing instead is I'm telling the pit controller, this is my current value, this is where I've moved right now, or this is how much my hand has rotated, etc., etc., etc. And I calculate, okay, where do I want to end up? How much rotation do I actually want to be? One thing that I also suddenly realize is the current pit controller is one-dimensional, and we need it three-dimensional, but we'll figure that out. Anyway, excuse me. So we're probably going to have a vector 3 pit controller and an angular pit controller that way. Might actually have to do that with Euler angles, I'm guessing. Go figure it out. Anyway, what was I saying? So yeah, so with the pit controller, we're telling it, like, here's where we are right now. Here's where I want you to be. And there's a bunch of values that we can tweak where we say, okay, in order to move from here to here, this is the value that we think that you need. Now, it doesn't have to be the exact value, but it has to be close to it. And it will do a nice little calculation based on those values we set. And it will say, like, hey, if you want to move from that value to that value, I think you need this much. And then the next frame, it goes, hey, I was expecting to move by this much, but I actually only moved by this much. So if I didn't move enough, I'm going to increase that value a little bit. Or if I've moved too far, I'm going to decrease that. And it sort of starts fine-tuning that movement, that control. Which is really, really, really cool. At least in theory, a lot of VR games use PID controllers to get this to work. Now, the downside of PID controllers is it's not an exact immediate application of force. It tries to do the right thing. Usually you tune the values in such a way that it's not going to get there. And then as it corrects for what is called the error, it's going to become more and more accurate. And obviously when suddenly you pick something up that's heavy, that changes that again, and therefore it's going to correct and work its way through that. But because there is a delay in it, sort of adjusting, that means that you will always have a bit of a lag in the movement of your hand. Your hand is not going to be exactly where it's tracked because the PID logic is trying to move the hand to that location and adjusting the values. So anyway, that is what we're going to try and do. Now, like I said, the linear movement is actually working because of a fluke of the engine, and potentially I am going to leave that the way that it is, but my angular doesn't. So let's go and adjust our linear PID controller to be an angular PID controller. However, yeah, that's kind of what Extra Tools 1 does. And that's still my backup plan, that if I can't get this to work the way that I want with proper joints and stuff like that, because there's a lot of advantages to joints. I've actually got a different test scene than the one that we're using right now, where I don't just have the object that I pick up, but the object that has sliders and other joints and stuff like that to create a completely interactive object. And that's really where this approach becomes really important. So anyway, so one thing that's going to be interesting is we're probably going to end up doing this with quaternions. Or am I going to do this with Euler angles? And then I need to do this 3 times. Well, we'll figure it out. Definitely going to go and rename this. All right, current angle, target angle. Dunk, dunk. Okay. So, and I'm just looking at the code that I have on my other part of my screen. Angle difference, load A, load B, returns a float, return A minus B plus 450. This is just to make sure, because we got a 360 degrees, we obviously got a point where we go from 360 to 0. So we need to do a nice little bit of code. Luckily, things are... Okay, what am I missing? Why is it complaining? I think this probably needs to be 0, and that needs to be good. And I need to use fmod instead of percent. So we're going to say fmod. So they can do it like this. And of course, hello, Baz. This is a good DD script. This is not C. There we go. So. Alrighty. So now our error actually needs to be this. Okie dokie. Cool. Is there anything else that is different here? That is the same. That is the same. This is different. This is again angle difference between the error and error lasts. And here again, same thing. Angle difference. And this is a divide by delta to get a rotation per second value. Oh, the distraction is okay, Packard. This helps me reset my thinking from time to time. I think that is good enough for what I want to do. Okay, so we basically have our pit controllers now. However, how am I doing this? So I wrote this code quite a while ago, so it's not completely fresh in my mind on how we're doing this. So here we are doing the apply force. So we're getting our velocity that we want. And I'm applying a central force. So that bit I'm happy about. We might eventually change that to a pit control as well, but not right now. Here, we're going to do a whole moment of inertia. We're going to get our current angular velocity. Current angular. So this is what we want to change. And we eventually need to do a torque value. Now, here's the thing. This is actually working on Euler angles, which is useful in this case. It's not working on quaternions. Although I'm guessing that we could rewrite this to quaternions if we wanted to, but I would need to figure out a better way to do this. Because that's the thing. I don't know a lot about scaling quaternions. That's the thing that I've always been confused about. Quaternions are great for an orientation, but for velocity, they are troublesome. That said, do we now duplicate our No, we're just gonna create two functions for this. So here we're gonna say this is how we're going to deal with one angle. Okay, so that means that for all these, I actually want this to be a vector 3. So that's gonna cause a whole bunch of errors. This one needs to be a vector 3 too. I think if I do this, that will be all zeroed out. Okay, cool. Now, this is going to be our default float. That's cool. But that now means that we want to just use the X component for this. There we go. Where is that? Oh, this also products. Cool. And here we're going to have error lost, .x. Should have copied this first. Actually, let's do that. I'm going to change this back the way that I just did in a minute, but I want to make a copy of this first. Oh. And I'm going to do this vector 3. Actually, let's call it Euler, These are basically going to be Euler angles. I'm going to go and do this. And then we'll have to fix that up in a sec. Now I can go and fix this up and say that's going to be dot x, dot x, dot x, dot x. Integral gain dot x. Rate of change is going to be error allows dot x dot x. Okay, here as well. Dot x dot x. And there we go. So that's perfect. Now I want to go and create a vector 3 version of this. 3 vector 3. What I'm going to do here is return vector 3 angle difference a dot x, b dot x, y, z, y, z. And again, the bigger the Euler angles, the more imprecise this is going to be, but we're going to get close enough to what it is that we want to do. Okay. And this becomes a vector 3. This becomes a vector 3. I think in this case, I should do this the other way around, because else Godot might mess up the types. Okay, it's happy about that. Okay. Okay. Here we do the same thing. We're going to go the other way around. And then we add all three together. So in theory, that should work. So we could do something similar to the linear pit controller at some point as well, where, you know, we turn everything into vector 3s. If we just do the normal logic, we just use one component of those. But if we then use the vector 3 version of it, then obviously we do all three parts of it. So yeah, hopefully this will work. I have no idea if it will. So in collision heads here, what I'm going to do here is, if false, just to turn off the logic that we currently have. Okay. And I was going to say old logic. Keep that around. And let's create our new logic for rotation. So what we need to have here, well, first of all, we need our angular pit control. So the way that I've done that with my raycast is, you can see that there's actually a pit controller in here that has a type. So we're going to go and do the same thing for our hands. Now, one thing that is important there is that it's easier to tweak these numbers in the interface until we get them the way that we want. And then we can go and save that and make that reusable so that we have a default and users can override that default and create their own things. So for that, let's have a look at our raycast body. Back to going big. And let's see at our pit controller. So you can see here that we do that and then we preload a default. Let's go to collision hands. Somewhere here we have a nice physics thing. Physics. We got collision hands, teleports, weights, max linear force, angular. Well, we'll actually disable it at some point. And actually, this is going to now be replaced like this. So that's going to be angular pit controller. And we're going to get our angular one. And now I'm going to just disable that for now. Because obviously we're going to have a new controller that we manage there. Pit controller that manages the orientation of. All right. Cool. All right. Now, we actually don't have our collision hands here. We defined that on our main stage for now. I'm just going to work on our right hand. I'm going to leave our left hand alone. First, going to tweak our right hand, see if we can get that to be something that makes sense. And we can now see here that we have an angular pit controller, and that's empty. So we're going to go and create a new angular pit controller. That's eventually the one that we'll save, but for now we'll leave it this way. And we can go and set these. Now, the way that you sort of tweak a pit controller is you start with setting your proportional gain. That's the thing that tries to move your object or your orientation or whatever it is that you're controlling as close as possible to where it should be. And then you start tweaking with your integral gain and your derivative gain. So your integral gain, as you fall short of where you need to be, your integral gain will slowly accumulate and try and increase the value until it gets closer there, but it has a high risk of then overshooting. The derivative gain is the opposite of it. It looks at how fast you're changing. It looks at that you're likely to overshoot, and it sort of slows you down again. So there's a balancing act between those three components that makes sure that this whole system works. All right. So we're going to leave those all on default. We're not going to worry about that. Yeah, we're going to leave that on velocity. I always forget which one is better there. What am I using for? Yeah, I'm also using velocity there. I think velocity is actual movement. Well, yeah. Okay. So in collision hands, we now have our angular pit controller. I need to find out where were we. All the way. Actually, I should be able to just get physics process. There we go. So if we have a pit controller, we're going to do our logic. If we don't, then obviously no pit controller. We're going to do a calculator. We're going to do delta. And now, random person, thank you very much. I'm glad you are enjoying the tutorials. Okay, so now the thing is, I'm not going to worry about any of those. That's our current velocity. That's fine. We're not going to worry about those either. So we have a target, and we have our Okay, so here we're just doing a difference. But actually not what we want. So this is going to be our target dot bases dot get Euler. So those are Euler variables that we want to get to. Now we do our global bases dot get Euler to get the values where we're currently at. And then we get our pit value. And then we can actually go and apply our pit value as our torque, because what we're doing here is based on those rotations, we're going to try and tune our pit controller to get torque values that will make the movement that we want. Now, this is going to be horribly not right because we haven't tuned anything. We're at default values, but it will show us whether our hand is going to move very slowly, how much we're going to have to tweak. Now, the other thing, in theory, is that we should be able to live tweak this and then figure out how that works. All right. Oh, and of course, we have been programming too long, so Steam Link is no longer running. Hooray! Yeah. Okay. So let's try this again. Nope. What? You should be running out. Am I? Oh yeah, that's the other thing that I always forget. Yeah, such a mismatch. If you don't give it the time to start up properly, it is actually going to interrupt the getting Steam Link to run. All right, cool. Steam Link is back up and running. Woohoo! Cool. Okay. Now, I am going to be nice and... Oh, I actually did not want to do that. I want this to be smaller so that we can more easily see that. So, okay, here we go. Plunk. Ooh. The integral saturation needs to be... Okay. No, that is not what I needed to do. Because I can actually IS3 vector 3 is vector 3 because these do not need to be tuned individually. At least I don't think so. So we can just clamp it like that. Okay. See if it's more happy about this. Ooh, that is having a lot of problems. Ooh. Now the question is that because our values are way, way, way too big, which I think it is? Because, of course, one of the downside is these are... Actually, that's interesting. Collision hands. Okay. Applies a rotational force without affecting position. Force is time dependent and meant to be applied every physical update. So that's right. I think one of the things that we need to do here is do that times delta. I'm pretty sure that I do that with the raycast body as well. Yeah, exactly. Because I'm getting a force that I now need to apply per second. Okay, so Is that going to work immediately, or did I need to restart this? I probably need to restart this all the time. Okay. It's going like crazy. Let's just make sure that we just restart that just to make sure. Did I save? Yeah, I did save. Which ones? All right. Let's see if that makes it any better. Nope. All right. Let's go and break. First of all, big question is whether these are actually good. The other thing is torque being applied in global space? Because I think we're assuming this is in 2. So we got some big angles. They're obviously going to be completely crazy. Oh, ha 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 ha. These are in radians. These are in degrees. Yeah, that's not going to work, is it? So let's first go and, oh, and this should not be minus 100. This should be minus 180. Well, that should actually be minus pi. Yep. So this is going to be minus pi. This is going to be tau. And this is going to be 2 times. This wire is getting in my way. Tau. Oh. That's going to be minus pi 2 pi. Sweet. All righty. Let's see if that now makes more sense. Okay. Huh. Oh, yeah, this is a first frame. So current angle is nothing. Sorry, target angle. Oh, we're not tracking yet. Why is the current angle that? I don't know. Oops. Okay, so. Huh. The first one is very fishy because. No, that could be correct. Okay. Continue. Okay. Well, it's not floating around like crazy anymore, so let's see what it's doing. Well, it's slowly moving to where it needs to be, but looks like it's messing the angles up or something. It's slowly trying to get to where it is, and then it sort of goes and messes up. Okay, cool. So, in theory, I should now be able to go over here. Go over here. Let's see if I change it to 10. Let's see if it actually updates that in game right away. Yeah, it does, but trying to figure out what it's doing. Whether it's overcorrecting or whether the angles that we're getting. That's the other thing, of course, is can we just apply torque like that? That's the other thing. That's a big question. Why is rotational force without affecting position? A force is time dependent. Meant why physics update. Inertia is required for this to work. To have inertia, an active collection. So that's all in there. Applies rotational impulse without impulse time independent. Applying an impulse every frame. So the frame. Okay, so basically by doing the times delta, we are turning apply torque into an apply impulse. Or, yeah. All right. Thing is, I don't know right now if in order to just get the rotation in one direction correct. Actually, that's an interesting one. I want to see if that is so. Just to humor myself. What I want to do, first of all, actually, I want to go and break this up a little bit so that it's easier to read. And then what I want to do is do this times vector 3. I'm going to isolate one axis. Come on, stupid cable. I'm going to isolate one axis and see if it behaves as expected. It should now just rotate in. Oh, it should just rotate in one axis. And the big question is whether we can control this. Okay. Okay. What I'm wondering about, looking at this, is whether torque is applied in local space, which is very possible. Okay. Huh. Okay. Let's see if that is true. So let's make that first. Target local is global. Now I always forget whether it's target times global or whether it's global times targets. And then obviously this is going to be target dot basis. So that would now be that. And that would be that. Okay. Be very interesting if indeed. Actually, I should check. Oops. I do this again. Where's my cursor? Should actually check the old code because we should be able to deduct from the old code. It's not doing much better. All right. What do we do here? Target. Target basis times inverse. Oh, okay. Yeah, that's dumb. Hmm. Hold on. It was... Ah, we've got that the wrong way around too. Calculate current target. I've got target and current reversed. But seeing that we've got this calculating basically in local, I actually think that here we're going from nothing to that. Yeah, so current target. Current, we've reset to 0 because we're doing it in a local space. Target is that. Now, one problem here is that our accumulated rotations should actually rotate with. So the other option is that we actually go from current to local and global, but then in applied torque make it local. Don't know if that will work, but let's see what this does. Oh, forget again. It's so annoying. There we go. All right. Oh. I wonder if when I move my hand, if that already applies also a rotational movement. So, all right, I am going to, just for fun, I just want to see if this indeed is a local thing. What? Oh, this is puzzling, all right. Okay. It is possible that because we're doing it local now, then obviously isolating an angle isn't going to do much. Well, that's rotating very slowly around one axis. So, okay. Okay. I think we're getting somewhere. I'm pretty sure that we are indeed doing this in local. Let's go and take this out and just get our angles properly and see if it does something sensible now. All right. It's doing something, but it looks like it's moving in the opposite direction of what it should do. That might actually be something that I screwed up. Or maybe not. Let's have a look. But that is looking better. All right, so we do have current angle target. And angle. Is that the wrong way around? Oh, yeah, target angle, current angle. That's working the right way. Just reverse it and see if that makes a difference. Yeah. It's moving too slowly, but it's going where it needs to go. I don't know if you guys can see that very well, but the hand is ending up where it should be. It's funny how it sort of prioritizes each axis, but okay. Cool. So, all right, let's go and tweak. Let's make 10. Oh yeah, by the way, you just saw me sort of things move because it automatically switched from what you call it? From controller tracking to hand tracking. So I can actually put my controller down and then I can do hello. Actually, you probably put both controllers down for that. Here we go. So hey, hand tracking. That also works. I can even grab that. So anyway. Okay. So 10 seems to be too much. Let's go to 5. That's as long as we can see that it's vibrating quite a bit. All right. So let's keep it on 5, and instead, let's go and give it a bit of gain and see what that does. I should actually have an interface in here that I can just adjust some sliders and see what happens. That'd be cool. Well, definitely not adjusting fast enough. All right. Let's give it. Let's actually make sure that that is high enough. Let's also give it a little bit of derivative gain. I want to give it a little bit more proportional gain. Okay. Oh, that's way too much. Okay, is that because of my derivative gain or is that something else? Sorry guys, I'm just gonna go move that off the screen. You guys won't be able to see that right now, but hello, come on, switch your hand tracking, please. Shouldn't be so hard. Switch your hand tracking. There we go. Okay, so no, it's not that. Is it because I went to 7? Okay, there. My freaking headset is resting on my. Okay, was it because I've got this at all to do that? Okay. See if I crank that up, what happens now? No, that doesn't do much. What if I go back to 10 on that? That now follows it quite closely, but it vibrates. Yeah, it's not like that at all. It's not like that at all. What if I do a little bit of that? Okay, what if I... That's an error rate of change. Oh, what? End of the visible state. Why? Oh, this is one of those situations where I hate it when that happens. Because I'm moving my hand around, I'm testing, all of a sudden Quest decides like, oh, I can just go and think that you're doing some sort of... Now that's the whole thing actually about this, is that the tweaking should allow you to remove the wobble eventually. But yeah, no, it's still wobbling like crazy. Yeah, so the derivative gain is not working the way that I'm expecting it to work. Wait to velocity. Yeah, I really need sliders to see what actually happens. But I don't have a UI system yet in XRTools, so anyway, my derivative gain doesn't seem to really be doing much. But the proportional gain is pretty close to what it should be. Okay, I want to see, now that I've got this somewhat working, what happens when I grab this. Because no, I definitely cannot exert enough force. Because that's the whole thing. And again, that is where our integral should be coming in. That allows us to adjust that. So let's do a very conservative there. And I'm actually going to make my saturation way higher. Allow that to be lots high. So okay, so that is, I'm still overcorrecting, but is that now it's still not allowing me to do anything? What if I set that really high? Let's see how crazy that will do it. I think that'll screw it completely up. Well, it has enough strength now to do something with the box, but not doing with the box what it should be doing. Okay. And of course, now the box has fallen on the ground. Just want to see if that can compensate for... All right, I'm starting to wonder if this just doesn't work. Could be because we're doing things in local space, so the axes keep changing, so our integral gain won't actually work. And this is the problem, right, with Euler angles. This is where quaternions just work so much better. I'm going to have to do some more reading up about this and see how they do this in other engines, because either we need to use quaternions and then just slowly move the quaternion axis and the angle to where we need to be, or or we need to do something with working on the angles in... Yeah, don't do that. I didn't mean to grab... Yeah, I threw it on the ground and I was standing on the box. Yeah, there's some things to fix there. Okay, I'm gonna try one more thing, which I don't think will work. Well, actually, the first thing that I'm gonna do, just to make my life easier, is we're gonna save this. Assets. No, not assets. Heavens. Hands. I think that's where our hands. Oh, defaults. There we go. And I am going to go and do that. So at least it's applied to both hands for now. Okay, so the thing that I wanted to do just to see if that would work is that we're actually going to go and do target base get earlier. And now, yeah, Euler. So we do this in global space. And I'm going to do it is, I'm just going to go and localize that. Now, I don't know if you can do that with Euler angles. I don't think so, but you never know. It's a long shot. We might as well try it and see if that makes any sort of improvement to the logic. I thought so. You cannot treat Euler angles as a vector. All right. So let's undo this. Yeah, guys, I think I'm going to have to do some more reading up and try and figure out where to head with this. You fixed a bunch of other problems today, though. That was good. But this is nowhere near where we need to be. So either I'm going down the complete wrong path because we just can't do this with Euler angles, which is very likely because, you know, like the whole what you call it? Let's forget the name. Integral calculation is about momentum, but as we are moving our hand and as we are getting our Euler angles local, the orientation of those angles change, and they might even completely reorient themselves. So the integral will never work. And that is something that it could make work with quaternions. However, that would probably involve getting the quaternion not as a proper quaternion, but calculated back as a vector angle. Now, I think whoops. Didn't mean to do that. Just wanted to go to help for this. There we go. No. So yeah, we've got an axis angle here to create it, but I'm pretty sure. Yeah, we're going to get angle and get axis. So but then the problem is that we could get a rate of change adjusted by the pit controller, but how to then translate that to the torque that we need to apply. So we would need a proper torque converter. Yeah, I'm just going to have to do some reading, guys. I am not going to answer that on stream today. However, and we did do a lot of experimentation. We fixed a couple of bugs in walking around. We added a couple of things to the demo, which is nice. And we did do a lot of experiments on them, and we learned something from this. So, yeah, my next step is now to read up on how other people apply pit controllers to rotations, and then see if I can figure out what what I'm doing wrong here. I'm probably just taking too big a shortcut going from Euler angles to torque, because that really is that's a fluke. But yeah. Cool. Sweet. Okay, cool. Well, I hope some of you picked something up out of this and learned something from this. I think we still have a long road to travel before this works anywhere near to how it should be working. And maybe I'm going down the completely wrong path for this, but we will figure it out eventually. Cool. I'm going to leave it there, everybody. Thank you all for watching the stream. And I'm going to pick this up probably either in the weekend or early next week. I'm going to be busy with other things tomorrow. And either I'll have figured something out and report back on that, or hopefully I'll have some reading material that gives me other ideas to try out on stream. So, yeah, I'm going to leave it there. I'm going to wish everybody a wonderful Thursday, and going to do some more soon. So, see you next time.